Sometimes you can look up at the stars. And if you're careful, and it's a particularly dark night, and you're looking at basically the place where the sun went down to where the sun comes up, you might see a haze. Now, this picture that I have here for you is a enhanced camera on a really good day. Mostly it just looks like a place where the sky is slightly brighter. The night sky is slightly brighter. That's a collection of stars. It is a concentration of stars that run along the inside of this. We've known about this for a long time. People look up the heavens, saw these stars, and they thought of them, and they gave them various names. One of the names that stuck with us in a modern sense is something called the Milky Way. And so in other words, when we look out in the heavens, we see the stars, a thickness, a place where there's a lot more stars than other places. What are we looking at? How do we know what we're looking at? All right, well, some of the things that we end up looking at is this. This is the Milky Way Galaxy. It's not, some people are like, hey, this is a picture from the outside. That's really cool. You can't take a picture of the outside. That's 50,000 light years away. You know, don't take a picture from the outside. We've never been anywhere near the outside. On this scale, we are not visible. Our star is not visible. But just to give you a feel for this, the relative scale from end to end is approximately 100,000 light years across. That means the light emitted from here would take 100,000 years to get to here. Okay? We are about 28,000 light years out, which means we're near the edge. A better vision of the same thing was NASA put together a map a while back. This is our best guess of what the universe currently looks like. And then here is the sun's location, and here's the center of our galaxy, and this is our spiral galaxy that makes up our universe. Again, 100,000 light years across here. That's a lot of stars. How many stars? About 200 billion with a B, billion. 200 billion stars. Each one, near as we can tell from our limited testing ability, has planets that go around them. At least 5, 6, maybe 7 planets per set. So that's 200 billion stars in our galaxy. And again, we're not near the center. We're out here. Those who just point out being center, just be aware that here is a bunch of binary stars and black holes and things like that. The radiation just being in this area would wipe out everybody on this planet many, many, many times over. So we're happy to not be there. So how do we know what we look like? Well, this is another collection of stars nearby. These collection of stars we're going to call galaxies, like we called our own the Milky Way Galaxy. This is Andromeda. Andromeda looks like this. And again, this spiraling look out there. Another choice. This here is an ecliptic galaxy. Ecliptic means it looks like an eclipse, right? Ecliptic galaxy. Moving forward, here's an irregular galaxy. And then here's another spiral galaxy. This is Messier. Okay. Again, this is 200 billion stars. Or more. Most of them are bigger. It's my favorite galaxy. This is called the Sombrero Galaxy. It's nice because it's edge on. We can see this galaxy edge on. And so we got several pictures of it. This is a real life. This is the right coloring of a galaxy. It's very far away. But again, with the Hubble Space Telescope, you can take a really pretty picture of 200 billion stars going around a central core. This is this central bulge in the middle, which is made up of hundreds of thousands, hundreds, maybe 100 billion stars are in this area in the middle here that you're looking at. Okay? So the galaxies come in a couple different flavors. We know they come in bars. This is the bar galaxy. There's a stick in the middle and these wings hanging off it. We know they come in spirals. Oh, sorry, this is ellipses. This is an ellipse. So it's an egg-shaped galaxy. Again, looks like it's churning. Irregular we think happens when bad things run into each other. And then here's our spiral galaxy. This is Messier. Okay, so they come in 4 flavors. Those 4 flavors are spiral, bar spiral, or just bar galaxy. They come in ecliptic and irregular, meaning a mess. Okay. Now, what these all have in common, which is interesting, is they all seem to be spinning. We need to know that because that's important. So the ones like bar galaxies end up looking like this. You know, with a bar in the middle, churning. Okay, it'd be better if I'd drawn it like that. Oh well, let's do it again. I can do this. I can do it. It can be done. I have to have two legs. There you go. I got it. That's what our galaxy looks like. Then there's spiral galaxies. And then there's ecliptic, which look like a whole bunch of stars. 200 billion stars here, and it's turning this way. 200 billion. I'm going to keep saying 200 billion. Okay. Now, that means that if you were to try to visit, it would take 200 billion. If you were able to teleport to each star, it would take you 200 billion trips to find each star. If you could do one a second, how many years would that take you? 200 billion. I'm going to do some math here. 2, 3, 1, 2, 3. You can do it with me if you like. Divided by 60. So it'd take me that many minutes. Divided by 60, that many hours. Divided by 24. Divided by 365. Oh, it'd only take me 6,341 years if I could teleport instantly to each star and visit them instantaneously. That's how many stars are in the heavens in just the Milky Way Galaxy. And again, the distances are vast. 100,000 light years. You can't go near the speed of light. You get 100,000 years to get to the farthest stars from us. That's actually light, more like 72 million light years or to get across there. So I'm sorry, 72,000 years to get there if you could travel the speed of light, which we can't do. And you're thinking, okay, that's cool. Nice fun fact. Hey, how many galaxies are there? It's an interesting question. We were asked scientists that same exact question. They said, how do you figure out how many galaxies there are? So they went out and they did something called the deep field study. What they asked the Hubble Space Telescope is pick a random place in space where there are no stars, okay? Where there's not a big star right in the middle obscuring your view. So pick one of the random places where take a picture that would be equivalent to a pinhead held at arm's length. You take a picture of a piece of space that would be equivalent to the pinhead, and when you're holding a pin at arm's length, this is what they came up with. And again, this was initially a random one. They did several of these. This is the first one they did. Oh yeah, here it is. I went past it, sorry. Here it is. And you're thinking, okay, cool, lots of stars. Those aren't stars. See the galaxy, see the galaxy, see the galaxy, see the galaxies. Hey, if you're looking for a star, that's a star, that's a star, that's a star. Because of the optical refraction, they end up having these funny little crosshairs on them. Everything else in this field, this is a pinhead held at arm length, a random spot in space. These are all galaxies. Every last one of them. Except for, that's a star up there. That's not a galaxy. How many galaxies are there? The answer to the question is there are 2 trillion. That's with a T. 2 trillion. There's 2 trillion galaxies. Each one has about 200 billion or more stars in them. There are a tremendous number of stars in the heavens. How many are there? Well, the simplest example that astronomers like to use, because they like to make fun of Earth scientists, is this. They say this: if you were, how are stars related to sand, grains of sands on the planet Earth? Okay. Obviously, there's a lot of grains of sands on the Earth, right? If you imagine how many bottom of the ocean, every beach, every place you could possibly sands in the desert, every place, which would be more, stars or grains of sand on the Earth? The answer to the question is there are a lot more stars than there are grains